Alright, welcome to Chapter 8, Section 1, called Angles of Polygons. This is for IM2, or Integrated Math 2. So a couple things we'll go over here before we get started. The first thing that you should see is the due date here. I don't see it on my teacher preview, but you'll see it on your student screen. The second thing is the number of attempts. There's always unlimited attempts on any of the homework assignments, quizzes, or tests. Number of questions, this just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is the one you keep. And partial credit is enabled, so if you answer 1 of 7 questions correctly, you get credit for 1 question, or however many you answered correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. What that means is once I click Start, down here in the bottom right corner, you will see a Submit Assignment button. I don't see it on the teacher preview again, but you will see it on your student screen. This is how you finish your assignment. So whenever I'm ready to leave this assignment, whether I have finished all the problems or not, I don't want to just close the tab or close my computer. I want to click Submit Assignment. It does 2 things. Number 1, like it said, you can't work on anything else. That means it's going to lock you out of all of your other assignments. So it won't let you work on anything else. The program assumes you want to leave this attempt open. Remember, you have unlimited attempts, so you don't need to leave this attempt open. You can work on this as many times as you want. The other thing that it does when you click Submit Assignment, the Submit Assignment button, is it affects the gradebook. So that means that your teacher can actually see what you've been working on, and it hopefully will make a positive change there. Alright, so on the side we always have these 3 tools, explanation, example, and message. So explanation tells you you're going to lose your current question attempt because it's going to literally give you the question or the answers to this question. Example will give you an example, something very close to what you're looking at. So this graphic is actually on the notes page that you should have in front of you, definitely, so that you can see this one, because this is how we're going to identify these polygons. This is how we're going to classify them, is using the number of sides that they have. So once you go through and you understand what it wants you to do in the example, you can close this, you can open another example, it'll give you a brand new one. Same graphic on there as far as the naming goes, but it'll give you 3 new examples. And then you can also message your teacher directly from the screen so that we know where to come help you, because it attaches a picture of the problem you're working on. Alright, so let's go ahead and look at these ones. So answer the questions about the polygons below. So it says, which figure is a heptagon? So I'm going to look at my notes page here, and I can even pull that one kind of over here so we can see it just for a moment. So this is the notes page that you should have, something like this. And a heptagon I can see has 7 sides. So I want to come over here, and I can count the sides, or I can count the vertices, the dots. So this is 4-sided. This is 1, 2, 3, 4, 5, 6, 7, 8. So it's 8-sided. That's an octagon. 1, 2, 3, 4, 5, 6, 7. So that's 7-sided, or it has 7 vertices. So figure C is a heptagon. A triangle has 3 sides. I don't even necessarily need to look at that. Hopefully we know that a triangle has 3. So none of them have 3 sides or 3 vertices. And which figure is a quadrilateral? Well, quadrilateral is any 4-sided figure. So that would be figure A. So none can definitely be an option here. You just have to pay attention, to which one it's asking you to look for there. And my silly screen froze. I just wanted to get that out of our way. All right, so it says find the value of x. So again, I'm going to go ahead and click on the example, because one thing they do tell you in here is that if you have a quadrilateral, and I have to scooch it over to see this, the sum of the angle measures of a quadrilateral is 360. Well, we were learning before that if we have a triangle, that it's 180. So we have 180 degrees. Well, if I just give it another point, and I do that, basically I'm just giving it another triangle, right? So we can kind of always divide these up into triangles however we connect to these vertices. So that's why they add up to 360, just kind of a quick why. Why does that work? So if I come back over here and I'm looking at these pieces, I have 126, I have 85, and I have 74. I'm going to add these together, these 3 angles, because I want to know how much of the 360 have I already used. So let's see, I have 9 plus 6 more. Well, actually, I could do this even a little easier. Here's 10 plus 5 more is 15, using compatible numbers there. And then 8 and 2 make 10, so 17, 18. And then 11, or 2 plus 2 is not 11, it's 2. 1 plus 1 is 2. I said 2 plus 2. I'm just losing my mind on this video. So I've used 280 already. Remember, 285. I only have 360 total within the quadrilateral. Doesn't matter what shape it is, as long as it's a convex quadrilateral. And what convex means is I don't have something like this, which this would be a pentagon because I have a 5th point here. But I don't have anything caving in. That's called concave. Convex means that all the points are kind of outside of the body here. So nothing's inside, nothing caves in. It's kind of an easy way to remember that. All right, so we're going to borrow, and we get 5. We're going to borrow again, and let's see, we get 2, 7, so 75. So this guy has to be 75. All right. This is another one. We do need the formula for this one, because this one, we start to get a little different with this one. So if it's a quadrilateral 4-sided, then it adds up to the 360. Once we start getting more sides, what we want to do is remember this formula here. S equals 180 times n minus 2. What this formula does is it'll allow us to calculate the total angle measure. So the sum of the interior angle measures for a certain sided figure. So if it says it's a 17-gon, that means it's 17-sided. And this stands for the number of sides. That's what the n stands for. S is just the sum. Is kind of an easy way to remember what the capital S stands for. So they want the sum of the interior angle measures of a 15-gon. So I have 180. It's 15 minus 2. And we can even think about this too. If I were to try to draw this, which I'm not even going to attempt to draw a 15-gon, 15-sided figure. But if we were thinking about a triangle, why would this formula work? If I did a triangle, it has 3 points, or 3 sides, so I do 3 minus 2, which would give me 1. 1 times 180 is 180. So really what we're doing is we're kind of taking away those first 2 points that made the very first triangle. That's kind of the why we're subtracting 2. And then after that, as long as we only subtract the 2, then it still works correctly throughout the rest of the formula here. So we have 180 times 13. So I'm going to actually stack that 13 really quick because that's a little easier for me to multiply there. So that's 24. That's 3, 4, 5. And then I have 0, 8, and 1. Whoops. I don't know why I did that. Grab one of the tools there. So that's 8, 9, 10, 11, 12, 13, and 2. So 2,340 degrees total. That's not one angle, that's the sum of the interior angles. So that's all of them put together. All right. I'm going to go ahead and erase this stuff just because it's getting a little too crowded here. I do need to keep this guy. I'll just move it up here because we do need to keep this in mind. So the sum of the interior angle measures of a convex polygon is 1,260. How many sides do they have? So in the last one, we knew the number of sides, and we solved the right side here to figure out what the left side is. This time, they're telling us what the total is, and they're asking us to find n, like this. So we just fill in what do we have, and then solve for the remaining variable. So they may give you the number of sides, they may give you the total sum, just like they did here. You can do this, a couple ways. I can distribute this 180 like this, or I could divide both sides by 180, and they actually gave me a calculator. So I'm going to go ahead and use my calculator tool there. Ooh, wasn't typing it in. Divided by 180. So I get 7 equals, and 180 divided by 180 cancels out because it becomes 1. So I have n minus 2. I don't need the parentheses anymore because there's nothing being multiplied by that binomial anymore. And now to find my final answer, I'm just going to add 2 to both sides. 7 plus 2 is 9, and 2 minus 2 cancels out. So the number of sides is 9. Right? Okay, so with this one, oh, I forgot I don't have that other tool piece open here. So we do know the number of sides on this one, and we don't know the total angle measures, but we know almost all of them. We're just missing one, right? But I need to know the total so that I can add up what I'm using and subtract that from what the total is to figure out what is this one little missing piece here, right? So I need to do this math really quick. Go S equals 180 times 5. So S equals, let's see, that'd be, not 5, 40. And that'd be 900, right? So now I do need to go through and I need to add all of these up really quick. So I have 130, 128, 112, and 142, and then 92 down here. And I put the 92 down here because it was the only one without 100. If this is confusing to try to add like this, I would, you could definitely do it in pieces instead of trying to stack them all like this. That is a little bit much. And I want to make sure 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I know this makes 10. So 10 and then 2, 4, 6, so 16. And then let's see, this makes 10. So that's 10. And then I have 4, 5, and then 10. So that makes another 10. So that's 20 and then 5. So I have 25 there. Just kind of combining like terms. Or not like terms, but compatible numbers there. 1, 2, 3, 4, 5, 6, 7. So I have 756 of the 900. So I just need to subtract this because I need to know how much is left over. So I need to do some borrowing here so that I can figure this out. So I have 4 and 4 and 1. And that does look like a very obtuse angle. It looks pretty large. So 144 does seem reasonable there. All right, 2 more of these. Let's see. Okay, so it says find the measure of each angle and the exterior angle of a regular hexagon, which is a 6-sided figure. So they told us it's a 6-sided figure. If you didn't remember, let me see. I can't remember if this one gives you the little table again. It doesn't necessarily give you the little table again on this one. It does give you the formula again. So to find each interior angle, I need to know what the total angle is. And we also need to know what some of these words mean. Because it tells us that we need to find each interior angle, each exterior angle of a regular hexagon. And what that means is it's not just any 6-sided figure. They are all congruent sides or all congruent angles. That's what the regular means. All the sides are the same length and all the angles are the same angle. So if I know the total number, the total sum for the 6-sided figure, if I divide that by 6, it'll tell me what each angle measure is, right? So we're going to use that S equals 180 times n minus 2, so 6 minus 2. So I have 180 times 4. So I get, let's see, I get 0 and I get 32 and 7. So 720. And I want to take 720 picky calculator. And I want to divide that by 6 because there are 6 angles and each angle measures exactly the same thing. So I'm going to take that total sum and divide it up evenly. So each one of those angles is 120 degrees. So each one, I'm not doing the total sum anymore, I'm doing each one. That's why I'm dividing. The exterior angle is a little bit easier. I don't have to do a formula to find the sum. Always, on all convex polygons, the exterior angles add up to 360 degrees. And we can loosely relate this to kind of a circle. But with this one, what we want to do is the same thing. I want to divide this by 6 because it's going to give me that what each exterior angle is. And what it means by exterior angle, if I could try to draw this, let's see. I'm going to try to draw a nice... I'm already not doing a very good job here. I want them all to be the same angle measure, but I'm not doing a very good job there. So we're going to pretend like these are all the same angle measure. All of these are 120. Okay. I know I didn't do the perfect job there, but it's, you know, close enough. And each side is the same length. This is our regular hexagon. So if I think about the idea, without even knowing that they all exterior angles add up to 360, the exterior angle means that I've extended a side and I want to know what is this angle here outside. What angle did I just create? Well, if I think of a flat line and it's 120, then this would have to be 60 because a line adds up to 180. And I could do it this way as well. This side would also have to be 180 because it's still the 120 that I'm using to fill in the line. So each one of these would have that same 60-degree angle if I were to extend them in either direction. It wouldn't matter. So, and when I say they add up to 360, I mean all in the same direction add up to 360. So you wouldn't add them all up and then also go in the other direction too. That would give you too many. But in one direction, all the exterior angles will add up to the 360. All right, let's go ahead and check that guy, and we will do the last one. Uh-oh. There we go. All right, so the measure of each interior angle of a regular polygon is 162 degrees. Find the number of sides. So this is a lot like, I think it was number 3 or 4. We have this formula, right? And sometimes they tell us the number of sides, sometimes they tell us the total. Well, in this case, they're telling us each. I know it's a regular polygon, so however many sides there are, they're all the same length, and the angles are all the same. So each one is 162, but I don't necessarily know how many there are. So I have to take a little extra step. It's not just 162, it's 162 times the number of sides, or the number of angles. So that's my S, that's my total. Because remember, S stands for the total, the sum of the interior angles. And then I can rewrite this like this. I still only have N, so I can definitely still solve for this. I'm going to go ahead and distribute this 180 like this, because that makes it a little easier. 62N. So I'm going to go ahead and subtract 180 N for both sides because I'm bringing the N's together. And then we have our calculator here, so we can start calculating. 162 minus 180. So I do get a negative. Normally we don't want negatives when we're dealing with length or angle measures, but don't get, too crazy too quick, because part of this is that we're going to have to cancel this out, but this negative 360 comes down. And then I'm going to divide both sides by negative 18. Negative 18 cancels out, but then both of these negatives will also cancel out, because negative 360 divided by negative 18 is going to give me a positive number. So that negative cancels itself out. So the number of sides in this case is going to be 20. Alright, And the number of sides, the more sides you have, the larger the interior angles are going to start to become, and the smaller the exterior angles are going to become. So if the closer you're getting, to the 180, or yeah, the 180 mark, that's, the kind of maximum there for, because if you have a flat line, then you are making a vertex point. You're not making a turn point. But the closer you get to the 180, the more number of sides you're going to have. So the farther away you are from 180, or the closer you are to 0, the lower number of sides you can have. The lowest you can actually get is if we have a regular triangle, which is called an equilateral triangle, and we have all 60-degree angles here, because 3 is the smallest number that we can do for a polygon. All right, well, that was section 1, and I will see you in section 2.